What's up, everybody? It's Dan from SageMathTutoring.com, and here with a video for AP Calculus AB. This is an optimization problem. Multiple ways of going about this problem, but I'm going to present the way that I would go about it. So let's dive in. Find the side length of an isosceles triangle with maximum area that is inscribed in a circle of radius 4. All right, so we can, of course, draw a circle of radius 4. Not a bad idea. Here that is. And drawing a triangle inside, not a bad idea. Here that is. And let's make it look good here. Okay. And we want to maximize this area of the triangle. Now, it's the case that very often you're going to want to um, position diagrams like this in the XY coordinate plane perfectly centered in the origin. So we can imagine we have an XY coordinate plane that kind of goes through like that. And this is at 0, 0, 0 or whatever. Now, we are maximizing the area. So of course we want to remind ourselves of this. And we know that the radius of this thing is 4. Now, the way that I had gone about it in my session with my student is I acknowledge that this green part is 4, and I'm going to say that this yellow part, we're just going to call that y. Okay, so that's some variable, and we're going to call this um, red part over here x. Okay, and this is x comma y. All right. Now, let's be very clear. The triangle um, area is without question um, the following. It's going to be 1/2 times the base, which is 2x. Hopefully that's clear, right? And 4 plus y. Now, here's one of the areas where it got confusing when I was talking to my student about this problem before. Let's really think about the actual triangle. Let's forget the XY coordinate plane for a moment. And I think my student watching acknowledges, in fact, she may have even acknowledged this on some level during the session, but this whole base of the actual triangle, well, that's 2x, yeah, definitely, right? And then this whole height is clearly 4 plus y. Now, um, we could say that this is most definitely 4, of course, but then this y part, we're taking the positive distance here. Okay. Now that's one of the areas where it got confusing because I'm looking at this y and I'm seeing it as being below the x-axis, so I'm assuming it's a negative y, right? But remember, when we're actually calculating the area, it's almost like we want to think about this triangle instead. I mean, this is clearly a positive distance that we need to take into account, and then we need to add that to 4. Similarly, I chose this to be x, but there's an x over here, and on the xy coordinate plane, that would be a negative x. But once again, reverting our attention to this triangle, we can very clearly see that we want this positive distance here as well. Okay, now that justifies this formula. Okay, now what is my point? My point is, regardless of whether or not this y coordinate down here is negative, when it comes to the actual area function, we want this y to be a positive value. It's almost like whatever this y is going to be the absolute value of this. All right, so that's a thing, that's a little detail that tripped me up with my student, and hopefully my student is watching now, acknowledges that. So anyway, the rest of what I had done should work out just fine, and that is to Acknowledge the circle formula, which is that it's x squared plus y squared equals 16. If the radius is 4, it's clearly the case that y squared equals 16 minus x squared. It is the case that y equals plus minus 16 minus x squared. Now look, right here is the moment of truth. I could say 4 minus radical blah, or I could say 4 plus radical blah. But remember, we are taking into account the absolute value of y, right? That's kind of what I said before. We're taking whatever this distance is, we might as well be taking the absolute value of that distance. So we want the absolute value of this. So that means we will be getting a positive out of that. So what that means is this ends up becoming 1 half times 2x times 4 plus radical 16 minus x squared. So that turns out to be crucial. Now I think my student watching can see these twos cancel, and then we have this, right? Then distributing the x, we end up with 4x plus x times radical 16 minus x squared. And then, yes, just taking the derivative, that's going to be 4 plus, um, we'll just do the product rule, right? 16 minus x squared, um, plus x times, let's be very careful, 1 half 16 minus x squared to the negative 1 half, and it's a chain rule scenario, so that's minus 2x. Um, that becomes 4 plus radical 16 minus x squared. The 2's would cancel, and it would be minus x squared all over the square root of 16 minus x squared. So let's just pause there because the reality is we've got some domain restrictions to take into account for the derivative. We know that this green 16 minus x squared thing, that has to be greater than 0, strictly greater than 0. It can't even be 0, right? Because then it would be an undefined fraction. But furthermore, whatever's under a radical needs to be positive, right? So it's the case that if you were to kind of work this out, you would see that x has to be between -4 and +4. So that is sort of a restriction on the domain. Let's see. Anything else worth talking about? I don't think so just yet. So anyway, that is the situation there. And we could just kind of make this mental note because that's going to come in handy later. Now, of course, we are to go on our mission, which is to set this equal to 0 and solve for x, right? So we can set this equal to 0 and go on our mission to solve for x. I think my student watching would agree that a decent idea, well, you could always get a common denominator, but I'm actually going to just multiply everything by this, what I would consider to be a troublesome denominator, and that is to multiply everything by this. All right. So this is kind of different than what I did with my student earlier, but hopefully she understands that in a sense, I'm just clearing the denominator right here by doing that. And you're allowed to multiply this side by radical 16 minus x squared as long as you multiply the entire other side by radical 16 minus x squared. So we're not doing anything against the rules. So this is that. Then we end up with this. This literally just becomes this, the next part, and then we have successfully cleared this fraction over here. Now, in case there's any question about this, this just is such that the radicals would cancel, and then we have just 16 minus x squared left over. So then going further, we have 4 and that, and then we have plus 16 minus 2x squared. Let's get all the non-radical stuff on the other side. I think my student watching would agree that that would result in 2x squared minus 16 all over 4, and that equals this. That's x squared. Now, let's divide everything over here by 2. And we'll square both sides. Now, as a result of squaring both sides, down below, of course, we would have 4, but up here we would have x to the fourth minus 16x squared plus 64, and that equals this. And really, we should be setting this equal to 0 because it's kind of like a quadratic-ish situation, right? So, let's see. I don't know. I want to multiply everything by 4 right now because I don't want to deal with that denominator. So hopefully my student watching recognizes it would result in this. Now we can set it equal to 0. So we are looking at we're looking at x to the fourth minus 12x squared equals 0. Factoring out an x squared, we end up with this. Clearly, due to this, x equals 0 as the critical value. And this is such that x equals positive negative radical 12, aka positive negative 2 radical 3. Okay. So um, we could say these are the critical values. Now, let's go ahead and perform a test to just find out where the maximum is. Now, of course, we'll put 0, we'll put this, and we'll put this. However, let's also remember that there was a restriction on the domain here where we had discovered that whatever x is, it's got to be between -4 and 4. So let's put that over here. Let's put 4 over here, and I'm going to put these like holes here. All right. Now, on some level, we can use sort of common sense as well. Like we know x is not going to be 0. I could even tell it's going to be this. And the reason for that is because, once again, makes no sense for x to be 0 here because then we wouldn't even have a base. But it also makes no sense for x to be negative, right? Because whatever this base is, remember, the base is 2x, right? Had already committed to that. And right here. And therefore x should be positive, right? Because we want it to be a positive base times a positive height times 1/2, right? So I already kind of see where this is going, but nonetheless, we will go ahead and use the derivative, which was this, and just kind of find out what's going on with some test values. So here's the derivative. Let's remind ourselves, okay? And we will use test values. Now, what does that look like? That looks like saying, okay, well, what happens when we plug in certain values in for x, right? So that's what we're going to be doing. Now, let's be very clear. -2 radical 3 is approximately -3.46, and this is, of course, positive 3.46. So when it comes to the actual test values, we can do negative 3.5. We can do negative 1, we can do positive 1, and we can do positive 3.5. And let's go ahead and do that. So if we were to plug in this negative 3.5 here, or yeah, negative 3.5, when I put that in my calculator, I get negative 0.39-ish. So that means that this is going down here, right? That's a negative. Now, when I plug in, when we plug in negative 1 into this, and when I put that into my calculator, that becomes, let's see, approximately, these approximation symbols, approximately 7.61-ish. So clearly we're going up here. Now, let's also, of course, plug in positive 1, but I don't even feel like I need a calculator for that. Because if this was a positive 1, wouldn't it just become positive? This would have just become positive. This would have just become positive. So it's really the case that this is just going to produce the exact same 7.61. So that is also going to be positive there, right? And then finally, we will plug in that positive 3.5. I think we all see where this is going. And when I use my calculator for that, I end up with approximately negative 0.39, which is sort of like that right there, you know? So that is negative. Okay. So where's the max? The max is this, okay, 2 radical 3. So going back, um, x is 2 radical 3. Okay, let's just write that down. Let's remind ourselves what they're asking for. Find the side lengths of the isosceles triangle with maximum area that is inscribed in a circle of radius 4. Well, if x is radical or 2 radical 3, why don't we draw our attention to this triangle here? I think we understand that that triangle, first of all, we have a 90-degree angle there. We have this is 4 plus y, and this is x, and we'll call this z, right? Hopefully we understand that it's that side that we're trying to find. That's at least one of the side lengths. We'll call that z. I think we understand that that is z as well, right? This is 2x, so that's going to be easy. In fact, we could get that over with. The 2x part um, is going to be 4 radical 3, right? So that's one of the side lengths. That's the side length on the bottom. Now, let's go on a mission to find out what z is, which is right here, and that's also z. So uh, my student watching, I think, understands that y is really radical 16 minus x squared, according to this information, right? So we really have 4 plus radical 16 minus x squared there on that side. And then we have x, and then we have z. So Pythagorean theorem, of course. So that's going to be 4 plus 16 minus x squared. Now, we can substitute 2 radical 3 in for x right now. So we have, 4 plus 16 minus 2 radical 3 squared, and that whole thing is going to be squared plus 2 radical 3 squared, and that's going to equal z squared. So what are we looking at? We are looking at 4 plus the square root of 16 minus 4 times 3, right? Plus 4 times 3, and that's going to equal z squared. We are looking at 4 plus radical 4, I guess, right? Plus 12, and that's going to equal z squared. This is 4 plus 2 squared plus 12 equals z squared. So 36 plus 12 equals z squared, and that is 48 equals z squared. So clearly z equals, and we're looking for positive numbers, so that's z equals um 4 radical 3. So we already discussed that the side length on the bottom was 4 radical 3. Turns out that z is also equal to 4 radical 3. So that's 4 radical 3. This has to be 4 radical 3 because it's isosceles, and we already discovered that that's 4 radical 3. All right, so very challenging problem. Hopefully my student watching understands. But anyway, yeah, that's how you do that one. Hope you liked it.